Hello everyone, myself Netravati, studying at Sri Venkateshwara College of Engineering. Today's my topic is design of MOSFET driver circuit for DC to DC converters. Subject Electronic Principles and Circuits, Department of Electronics and Communication Engineering. So let's see the topic. Introduction to MOSFET driver circuits. Introduction to MOSFET driver circuit. MOSFET drivers are essential components in DC to DC converters for efficient power management. They serve to switch the MOSFETs on and off at high speeds, which is critical for minimizing power loss. Understanding the design of these drivers is integral for optimizing converter performance and reliability. So let's see the importance of MOSFET driver in DC to DC converters. MOSFET drivers provide the necessary gate voltage and current to rapidly switch the MOSFETs. The speed and efficiency of the converter heavily depend on the characteristics of the driver circuit. Properly designed drivers helps to reduce electromagnetic interference and heat generation. Key parameters of MOSFET drivers. Gate drive voltage levels must be compatible with the MOSFET's threshold voltage for optimal operation. Rise and fall time of the gate drive signal influence switching losses and overall efficiency. The ability to source and sink sufficient current is vital for rapid transitions and reduced switching times. Types of MOSFET driver circuit. There are two main types: dedicated dedicated drivers ICs and discrete transistors based drivers. Dedicated drivers ICs often offer integrated features like protection and fault management. Discrete designs provide flexibility and can be tailored to specific applications requirements. Design consideration for high speed switching, minimizing parasitic capacity and inductance is critical for achieving high speed switching. Short and wide traces should be used to connect the drive driver to the MOSFET gate to reduce delay. The layout must be optimized to avoid ground bounce and ensure stable. Design considerations for high speed switching, minimizing parasitic capacity and inductance is critical for achieving high speed switching. Short and wide traces should be used to connect the driver to the MOSFET gate to reduce delay. The layout must be optimized to avoid ground bounce and ensure stable operation at high frequencies. Power supply requirements for MOSFET drivers. The driver circuit requires a stable power supply to maintain consistent gate drive voltages. Decoupling capacitors are essential for filtering noise and providing instantaneous current during switching. Adequate thermal management is necessary to ensure reliability, especially in high power applications. Protection features in MOSFET driver circuits. Integrated protection features can help prevent over voltage and overcurrent conditions. Gate resistor can limit inrush currents and dampen ringing during switching events. Implementing a fault detection mechanism can enhance the robustness of the driver circuit. Testing and validation of MOSFET driver. Testing involves measuring key parameters like rise or fall times, switching losses, and thermal performance. Simulation tools can be used to predict circuit performance under various operating conditions. Validation on prototype boards is critical to ensure the design meets specifications before mass production. Common applications of MOSFET driver circuit. MOSFET drivers are widely used in various DC to DC converter technologies, including buck and boost converters. They are also essential in renewable energy systems such as solar inverters and battery chargers. Industrial applications, including motor drivers and power supplies, benefit from efficient MOSFET driver circuits. Future trends in MOSFET driver circuits. The trend towards high efficiency and smaller form factors drivers innovation in driver technology. Integration of digital control and smart features within driver ICs is becoming increasingly common. Emerging materials and technologies will continue to influence the design of MOSFET drivers for next generation.